Dear students, welcome back in my class of CIS 3158 Mobile Applications and Game Development. Now this is part 4 video lecture of week 8, and in week 8 our focus is on alpha beta pruning. In the next slide I have highlighted the aim and objectives for week 8 session. So here you can see, you know about these two aims and 4 objectives. So far we have completed objective 1 in part number 2 video lecture, objective 2 in part 3 video lecture, and in this part, that is in part number 4, I will be covering how alpha beta pruning improves minimax search. So in order to explain the working of alpha beta pruning, I have given one example, and for the example we will apply the rules we discussed in part number 3 video lecture, that is rule number 1 to rule number 7. We discussed these rules in part number 3 video lecture of week 8 on alpha beta pruning. So we'll start the example. So here you can see one search tree. This is a search tree is given. This is my search tree, and for this search tree I would like to apply alpha beta pruning. So the rule number 1 and 2, which I explained in the previous video lecture, it says that initially the value of alpha and beta will be -1 and +1. So here you can see the value of alpha is equal to -1 and the value of beta is selected as +infinite. So what you can see here, alpha is less than beta, that is -infinite is less than +infinite. So we will not prune. Now what we will do, at this stage, we will start traversing this search tree, and we will first traverse in the left side, and then after completing the left side we will move to the right side. So this is left subtree, and this side is known as right subtree. Another important thing you need to keep in mind is this max, min, max indicates max turn, minimum player turn, max player turn, and the last is terminal node. So this max and min indicates the max and min player turns. So we will move to the last node, that is terminal node, that is here. So we moved here, then from this point we will move to this node, and then from this we will move to the terminal node. This is the idea. Now we will determine the value of alpha and beta at node D. Node D. So here you can see the alpha is 3 and beta is infinite, but how we got these two values? The question is that in order to determine the value of alpha and beta at node D, what we will do, we can see here the player max is taking the move. So we will determine the value of alpha at max by applying max 2, 3. For alpha is equal to, what we will do, maximum of 2 and 3 and it will give us 3. So value at node D, alpha value at node D is 3. So that is why this is 3. Alpha is 3. Now what we will do after finding the value of alpha at this node, and the value of beta is plus infinite. After finding the value of alpha at node D, will move to the node B. And what will happen at this node? We will find minimum, because here min player will take the turn. So minimum, what is the node value at D? Node value at D is 3, because here you can see we got 3 by comparing maximum. So node value at at vertex D is 3, and the value at node vertex D, beta value at node vertex D is infinite. So the node value is 3 and the beta value is 3 is infinite. So what we will do? We'll check which one is the minimum. Of course 3 is the minimum, so we'll select 3. So alpha at node B will be infinite, minus infinite, which you can see here, and the beta value at node B is equal to 3. So alpha at node D is 3, whereas beta at node 3 is plus infinite, and the node value at vertex D or node D is 3. What we did here, the alpha value is minus infinite, and since beta min player is taking the move, and min means beta value, so here we are finding the beta value. So beta value is 3, and how we got this beta value? Minimum between the node value at D and the alpha beta value at D. So it gave us 3. So that is the reason beta is 3. Now next we'll see in the right side of the node. So after completing this part, we completed this part. Now we will move to the right side of B. So here again you can see we will move to the E, and the rule says that this node will pass the value of alpha beta to the successor node. So from this we got alpha value at this node is minus infinite, and the beta value at node is 3, because it will transfer the value of alpha beta from node B to node E. Now here max player will take the move. So max value, so 5 will be compared with minus infinite. So 5, when we will compare it with minus infinite, so what we will get? Which one is the maximum? 5 is the maximum, so we will get 5. So node value at this vertex is at this node is 5, and alpha value is 5 now, and the beta value at node E is 3. So it indicates that, what does this mean? Alpha at node E is 5 and beta at node E is 3. What does this mean? It means that alpha is greater than beta. This is the rule number 3 I explained in the previous video lecture. So if this rule is true, what does this mean? It means that we will prune this part. So that is the reason you can see the cross is given here. So we will not going to determine what is the value we will get at this side, that is in the right side. we'll prune this. And then what we will do after doing this, we'll move the value of alpha and beta to this node, that is to the node A, and it will come from node B. So what we'll get here, I have given in the next slide. So now at node A, alpha value will change will be changed. So here max, initially the value of alpha at node A was minus infinite, so minus infinite comma 3, because 3 is the value here. So here we will get alpha max, that is alpha at, that is maximum is 3, so alpha is 3 now. And beta, there is no change in the beta value, so beta will be plus infinite, because max means we are finding only for alpha and min means we are finding for beta. Now what we will do, we have already completed this part. Now we will move to the right side. So we will transfer the value to node C. So here we are transferring the value of alpha and beta to node C. So here you can see the value of alpha is 3 and beta is infinite. Now it has another branch, so we will move to the left side and it will transfer the value to F. And here we'll find this is the node for max player. So max player will take the move. So here alpha value is 3 because this value is transferred to the node F. So here the alpha value is 3. So what we'll do, we'll check with these. So maximum 0, 3, because alpha value is 3 and the node value at this node is 0. The node value at this node is 0. So 0, 3, it will give us 3. And then we'll check for this. So now the value of alpha is 3 after comparing this node, that is this node, with the alpha value at node F. Now we will check for max value between 1, that is node value is 1, and 3. So here we'll get 3 again because the maximum value is 3. And the node value at F is 1. So you can see here the node value at F is 1. So alpha value at F is 3 and node value at F is 1. Now what will happen at this stage? Now what will happen? It will transfer the value to C. Now we will determine the value of alpha and beta for C. So this is for min, so we will only determine the value of beta because we will get the value of alpha, which is at node C is 3, and beta value will find out at C because beta value will get updated. Now minimum between, what is the initial beta value? Initial beta value at this node was plus infinite, so we'll take plus infinite. And what is the node value at this is F. So what is the minimum value? Minimum value is 1. So the new beta value at vertex at node C will be 1. So that is why we got 1. Now what does this mean? Here you can see alpha value at node C is 3 and beta value at node is 1. It means that alpha is greater than beta, so prune it. So we will not select all these subtree, that is right subtree, we will completely prune. So this is how will work. So we have pruned this part and we have pruned this part. So we will not going to determine the value at this vertex, this vertex, this vertex, and this vertex. So by this way